All right, we're going to be on page 189 of your workbooks. This is chapter 9, section 2. So if you remember in section 1, we started talking about scatter plots and how it's a type of graph that kind of just has dots everywhere. They can be in some sort of relationship, either in a positive manner, in a negative manner, or there can be no relationship. They're just scattered everywhere. So what we're going to be looking at today are what are called lines of fit. How to draw a line through that series of points, because you saw in section 1 that they don't fall in a straight line. They're kind of scattered everywhere. So if you look at activity 1, it says you've been working on a science project for 8 months. Each month you measured the length of a baby alligator. Okay, and we have a table that shows the measurements. So we started in September, that's whenever you first measured, and then through April. So it says use the following steps to predict the baby alligator's length next September, so a year from whenever you started. So first thing we have to do is graph the data that's in the table. So again, we have the number of month that it is along the bottom and the length of the baby alligator in inches up the side. So at 0 months, it was 22 inches right here. And notice that break in the graph right here, that little squiggly line means there's a break from 0 to 22, and then it goes by ones. Okay? Month 1, it was at 22.5. Month 2 was at 23.5. Month 3 was at 25. Month 4 was at 26. Month 5 was at 27.5. Month 6 was at 28.5. And month 7 was at 29.5. Now, part B says draw a line that you think best approximates the point. So you can see these lines fall pretty well in a straight line, but not exactly. So what we're going to do is we're going to draw a line that hits as many of these points as possible. Okay, so you may want to use the straight edge of your binder or of another piece of paper to kind of help you make this straight line. But if I start at 22 right here, and I'm going to make mine as straight as I can, but no, it's not going to be anywhere near straight. So as I come up, I want to kind of pass through here and just keep going. Okay, so something like that. Now part C says write an equation for your line. So remember, our form for our equation of a linear equation is y equals mx plus b. Now whenever you do these, the b part is going to be the easiest thing to pick out. Where does it cross the y-axis? Well, it crosses at 22. The hardest thing to figure out is what's the slope going to be, okay? So if I just pick 2 points that I know cross through this line, I know 22 does, and I'll use this point. It's really close, close enough per se. You will come up with a different equation than other people around you, and that's fine because your lines won't be exactly the same. So as long as they are close, then it's going to be fine. So remember, we do rise over run. So on this graph, okay, I'm going to rise 1, 2, 3, 4, and I'm going to run 1, 2, 3, 4. So my slope is 4 over 4, which is 1. So y equals 1x, or remember, you don't need that 1 there, plus 22. Now, D, use the equation to predict the baby alligator's length next September. Okay, so they told us that month 7 was April. That means 8 would be May, 9 would be June, 10 would be July, 11 would be August, and month 12 would be September. Okay, so we need to put in month 12, after 12 months have gone by, in for the month, which that's your x. So y equals 12 plus 22. And you get y equals 34. So our approximation for the length of that baby alligator after 1 year would be 34 inches. And if you kind of look at our graph, here's where 12 would be, and here's where 34 would be. It's really close to what my line was. And if I would have used a ruler or something, it would have been a better approximation of that. Okay, so we graphed it. Your line that you draw through there, your line of fit, best fit, you want it to hit as many points as you can while still staying straight. Okay, if it can't hit any, you want to have about the same number of dots above the line that you do below the line. And we'll look more at that in a little bit. Okay, moving on to the next page. Okay, it says you are a biologist and study bat populations. You are asked to predict the number of bats that will be living in an abandoned mine in 3 years. To start, you find the number of bats that have been living in the mine during the past 8 years. Okay, so we had when it started 7 years ago, and then after 1 year, after 2 years, and so on. And keep in mind, this number right here, the number of bats is in thousands. So it's not 327 bats, it's 327,000 bats were measured at that time. Okay, so we're just going to do the same thing that we did with the previous example. Okay, we're going to graph the data in the table. So 0, year 0, it's at 327, which is about right there. 1 year, it was at 306. 2 years was at 299. 3 years was at 270. 4 years was at 254. 5 years was at 232. 6 years was at 215. And after 7 years at 197. And again, all of these dots I kind of just approximated. Okay. B, draw a line that you think best approximates the points. So again, I'm going to try to draw this as straight as I can. And I want it to hit as many points as I can get it. Okay. C, write an equation for your line. So again, we'll follow this format, y equals mx plus b. Again, your y-intercept, where does it cross the y-axis? And that is up here, and if you remember back from the table, that was at 327. So 327, we just need to figure out what the slope is. Okay, so if I pick another point that went through, let's say right here, that was at 270. So if I go down, I'm going down from 327 down to 270. So I've actually gone down 57, so that's a negative 57. And I've gone right 3. Okay, now what's going to be easier? To have this be a really nasty fraction like negative 57 over 3, or could I go ahead and round this up and say it started at 330? That way I came down an even 60 and went over 3. That would give me a nice even negative 20 for my slope. That's going to be a lot easier to deal with. And we mentioned in the last example that these lines of fit, these lines that you draw, aren't going to be perfect. Okay, they don't have to go through a certain number of points. You can use whatever point you want. It just has to hit a majority of the data. So we're going to round that slope up and say it's a negative 20. Now, D, use the equation to predict the number of bats in 3 years. So year 8, year 9, we're basically predicting how many bats there will be after year 10. Okay, so we'll just plug that into our equation. We have negative 20 times 10 plus 327. So we have negative 200 plus 327, and that would give us 127. Remember, that was in the thousands. Bats at that 10-year mark. Okay, moving on to the next one. Over on the next page. Number 3 says, how can you use data to predict an event? Okay, so what we did is we plotted the points, plotted the known points, because we knew those to be true. Then we created a line of best fit, which is what that line is called. And then we just follow the trend in that line to make the prediction. Okay, because the data tells us it's going to continue to go on in that same pattern if it has up until this point. Okay, now your assignment to go with this is going to be on the next page, page 192, the 9.2 practice to go with this.